Hello, hi, good morning. Once again, welcome to the chemistry class. So, in the last class, we have started, that is, completed the four laws: gaseous law, Boyle's law, Charles law, Avogadro's law, and Gay-Lussac's law. So, I hope you remember we are expressing these four terms, four laws on the basis of four terms, that is, pressure, volume, gas, pressure, volume, temperature, and N, that is amount of substance. Based on these four terms, we are going to define these four gaseous laws. So in that four gaseous law, I would like to recall the last one once again, and we will compare the four laws. Means we are going to take only the three. So why you are going to study now? So look here, in the last one, that is Avogadro's law, which is going to relate the volume and amount of substance. So here we are going to say that at constant temperature, pressure, even at the fixed volume, means at constant temperature, pressure, and the fixed volume, the number of moles of gas remains same. What is that fixed volume of this standard temperature pressure? That is, I said STP. STP is nothing but standard temperature pressure. Why we have taken that the standard temperature as 0 degree? Why the standard pressure as 1 bar? Is why? Because the standard temperature and standard pressures are nothing but, here we are going to say, this temperature is the freezing point of the water. Means at this temperature, water is going to form a freeze. Freeze is nothing but it's going to form the solid compound. Water is going to form as a ice at the temperature 0 degrees Celsius. For that reason, we are considered as the standard temperature. And in the pressure, we have taken 1 bar or 10 raised to 5 Pascal as a constant or standard pressure. Why? Because this is the pressure exerted in the sea level. ಸಮುದ್ರ ಮಟ್ಟದಲ್ಲಿ ಏನಿರ್ತೈತಿ ಅಂತಂದ್ರೆ ಒತ್ತಡ, pressure is nothing but ಒತ್ತಡ. in ಕನ್ನಡ sea pressure ಅಂದ್ರೆ sea level ಅಲ್ಲಿ ಎಕ್ಸಿಸ್ಟ್ ಆಗುವಂತ pressure ಗೆ ನಾವೇನಂತ ಕರಿತೀವಿ? Standard pressure. We are calling that as a standard pressure. So standard temperature is nothing but it's the temperature at which the water is undergo freezes, and the standard pressure, why? Because the sea level undergo the pressure, it exists the pressure of 1 bar. For that reason, we are considered as a standard pressure. Because of these two values, we are considering the standard temperature pressure. At STP, we are existing some of the gases. At this condition, at standard temperature and pressure, the volume also constant. If volume is fixed, then the number of moles are always same, means it is equal. This is what the Avogadro law says. And coming to the next one, if the gaseous compound at STP, at standard temperature pressure, they are going to form, some of the gases are having the volume, not some ideal gases. So what are those ideal gases you are going to study right now? So at standard temperature and pressure, means at temperature this one and bar, means pressure should be in this values, then we are calling that as standard temperature pressure. In this condition, the ideal gas are going to have the volume, fixed volume will be there. What is that volume? Ideal gases at standard temperature pressure. The ideal gases, when the temperature and pressure is standard, then they are going to have the volume 22.71098 liter per mole. You have to remember this volume. This is important. The volume of the ideal gases. What means? I am going to tell you. The ideal gas at this temperature and pressure, they are having the fixed volume. What is that fixed volume? Fixed volume is nothing but 22.71098. This value, the volume assigned is liter per mole, means 1 mole is having this much of liter. So this is the volume of ideal gas at this condition, at STP. So you have to remember what is the volume of ideal gas at STP. If they ask you, so you have to write this volume value of the volume. Are you getting this point? So one more thing I would like to remind you. N is nothing but what? Number of moles of substance. N can be expressed as N is equal to, means number of moles can be calculated by M divided by capital M. M, small m is nothing but given mass, capital M is the molar mass. In the first chapter we have studied in the m and small m. The given mass is called as small m. Molar mass is nothing but mass of the 1 mole of compound NaCl. 1 mole NaCl का mass क्या रहता है, उससे क्या बोलते हैं हम, molar mass. Similarly here also small m is nothing but given mass. एक water now 20 gram water तोगोंड्रे 20 gram water now तोगोंडे means they have given that given mass is called as small m. But 1 H2O 1 mole इत्तंद्रे H2 इदावे oxygen is 1, so hydrogen 2 is having the mass 2, 1 hydrogen 1 mass, 2 hydrogen 2. One of the oxygen is having the mass 16 gram. One oxygen atomic mass is 16, therefore 16 plus 2 together it is 18. One water the mass is to 18, that 18 is called as molar mass. Andre 1 mole water mass itself is called as molar mass. Not only the water, you can take any of the compound. 1 mole of any of the compound is called as molar mass. Whichever they have given the mass, that is called as small m. Small m means it is their choice. How much they have given, that is molecular mass. How much we are taking, the mass of 1 mole of compound is called as molar mass. This is about the m. So for that reason we are going to substitute here V is equal to K, that is constant. Instead of n, I am going to substitute here small m upon capital M. Small m upon capital M. So this is also one of the kind of formula. So you may get the problems or may not, but you should remember this n is nothing but small m upon capital M. So let's begin the next one. So now it's a time to recall the whole terms. So here I have introduced the one term, that is ideal gas. What is this ideal gas? We know that gases is one of the matter among the solid liquid gases. So in that gases, the one is ideal gas. What is this ideal gas? So ideal gas are nothing but the gas only. It is a gas, but the gas which is going to obey the ABC. What is this ABC? I request you please don't say this ABC also, but only for your understanding I am telling the short form. The gas which obeys the Avogadro's law, the gas which obeys the Boyle's law, the gas which obeys the Charles law. Except this, guys, Charles law means it's not obeying this one. Means they are not saying that it's not obeying, but we are saying that the gases which obeys the Boyle's law, Charles law, and Avogadro's law at all conditions, at all concentrations. Means whenever you are taking any of the gas, that the gas should obey this Boyle's law, Charles law, and Avogadro's law. These 3 law has to be satisfied. For that reason, the gases which are satisfied these 3 laws, such kind of gases we are calling the gas ideal gas. We are calling the gas ideal gas. What is ideal gas? They may ask you. It is an important question. What is ideal gas? The gas which obeys Avogadro's law, Boyle's law, and Charles law at all concentration is called as ideal gas. So here ideal gas, here we are going to define this ideal gas by mathematical expression, and its formula is very much important. So look here. So I would like to take A, B, C according to the Avogadro's law. Can you see here? Avogadro's law, it's going to relate the V and N. Boyle's law, it's going to relate the PV, and Charles law, it's going to obey the V and T. Can you see here? In the Boyle's law, V is there. In the Charles law, V is there. In the Avogadro's law also, V is there. So it means that here one of the common term is V. For that reason, I would like to call from V only. So according to the Avogadro's law, first one, according to A I have written. So A is nothing but not to say according to Avogadro's law. Don't write here. So I have observed that sometime when I use the short form, means you are not supposed to use that short form. You have to write it long form. Why? Because the word is not so much extended. For that reason I am writing the short form. According to the Avogadro's law. According to the Avogadro's law. So what we have to write? Avogadro's law. So V is directly proportional to the N. This is according to the Avogadro's law. Similarly, Second one according to B. So according to B, what we have to write? So according to the Avogadro law, V is directly proportional to the N, and according to B, according to the Boyle's law is going to give the relation between pressure and volume. So volume is inversely proportional to the pressure. Volume is inversely proportional to the pressure. So V is inversely proportional to B. So third one according to C. C is nothing but you have to say that according to Charles law. According to Charles law, V and T. So again V is whether it varies directly or inversely. V is directly proportional to the temperature. As the temperature increases, volume also increases. Therefore, V is directly proportional to the temperature. So these three are the four conditions. Why? Because we have written individually. The ideal gas is nothing but the gas which is going to obey the Avogadro law, Boyle's law, and Charles law. Such gases are called as ideal gas. So here together we can say equation number 1, equation number 2, and this is equation number 3. So let's combine equation 1, 2 and 3. 1, 2, 3 we will combine. So here according to the V, what happens? Here V is directly proportional to the N. Directly proportional to the N. And in the second one V is inversely proportional to the P. So inversely proportional to the P. And third one V is directly proportional to the T. So V is directly proportional to the T. Are you getting my point? V directly proportional to the N and T. T and N are directly proportional. P is inversely proportional. For that reason, V is directly proportional to the N and directly proportional to the T and inversely proportional to the P. Keeping this one, so I would like to give a constant V is equal to, I would like to say a constant. In the previous we have taken the constant as K. Now here we are going to take a constant as R. So R into N into T divided by P. So I would like to change this one. That is, I am sending this P to the left side. Therefore, what happens? P into B is equal to R N T. I can write the however I want. First I will write N and R T. Are you getting this one? So this is next on this one. State the ideal gas and explain the term, or explain the ideal gas. If they ask like that for 2 marks means or 3 marks means, first you have to define the ideal gas. Ideal gas is nothing but which obeys the ABC. Means you have to express that individually. Don't say ABC. A means Avogadro, Boyle's law, and Charles law like that. And next, according to the Avogadro's law, you have to write this visually, and you have to write this expression combining 1, 2, 3, and we are going to get this formula, and we are going to replace the R as a constant, and we are rearranging this expression. Therefore, PV is equal to NRT. So after writing this one, you have to say or define each of the term. Where here P is nothing but pressure, V is nothing but volume, N is nothing but amount of substance, T is the temperature. Whereas R is the constant. R is called as gas constant, universal gas constant. So I hope this is the new word for you from today onwards. So R is nothing but it is a gas constant. So soon after writing this final expression, we have to define the terms. So this is about the ideal gas. So what is ideal gas? How we have to define this one, and final expression is the most important for your even problem solving. Okay. So let's see the next one. Okay, students, look here. So in the ideal gas expression, we have a last final expression, that is PV is equal to NRT. PV is equal to NRT, where P is the pressure, V is the volume, N is the amount of substance, R is the universal gas constant, T is the temperature. If we want to calculate the R value, R is nothing but gas constant, universal gas constant. Just to rearrange this expression, if I want the R value means, you keep this R as it is, and the remaining left side we are having P and V, pressure and volume. You just send this N and T to the left side. What happens? To the R, these two terms are having the multiplication. The function is multiplication. If it comes to the opposite side, that multiplication becomes division. Therefore, PV divided by N and T. N and, are you getting how we have arranged? PV is equal to N and T, the same expression when we made that for the R value. R is equal to PV divided by NT. The same expression I am sending you. So P is having the SI unit Pascal and volume is having the SI unit meter cube, and N is number of moles, that is mole, and temperature is Kelvin. The same expression I have substituted the constant value for pressure, volume, and amount of substance and temperature. Just look here. So same value I have arranged here to calculate the R value. So P is I have taken the constant. So we can take 1 bar, or that 1 bar is also equal to the 10 raised to 5 Pascal. So I have written in the form of Pascal, 10 raised to 5 Pascal, into volume I have taken as 22.71 into 10 raised to minus 3 meter cube. Why? Because 22.71098 was there. So I saved in the ideal gas are having the constant value. This is 22.71 into 10 raised to minus 3. Why? Because we are taking in the form of meter cube. That's why its value is 10 raised to minus 3 meter cube. And N is nothing but amount of substance. Here we have taken N as the number of moles as 1 mole. For that reason N is equal to 1 mole into temperature is 0 degree, that is Celsius in the form of Kelvin is 273.15 Kelvin. So by calculating these all terms, 10 raised to 5 into 22.71 divided by 273.15, we are going to get the value as 8.314. I have written the SI units as it is. Pascal is in the numerator, meter cube is also in the numerator, whereas mole is in the denominator. If denominator moves to the numerator, mole is having the value, mole power it is 1. So if it moves to the up, the plus 1 becomes minus 1, and Kelvin is in the denominator. If it moves to the numerator, Kelvin is having the power is 1. If it moves to the up, means plus 1 becomes minus 1. Pascal, meter cube, per Kelvin, per mole. So if I would like to change this Pascal, the SI units I have changed, means Pascal as a bar and meter cube as a liter. So if by changing this SI units of pressure and volume, then we have to multiply by 10 raised to minus 2. 10 raised to minus 2. So same thing here, I didn't change anything. The Kelvin and mole will be remain same as it is, but I have changed the SI unit of pressure, Pascal to bar, and meter cube to the liter. For that reason we have multiplied by 10 raised to minus 2. The same thing, why we have changed this one means by taking this 10 raised to minus 2 bar and liter, we are converting this in the form of energy, that is joule. J is nothing but it is the SI unit of energy, that is joule. The remaining everything is same, 8.314 joule. Joule is nothing but here 10 raised to minus 2 bar and liter. We are converted that in the form of energy, that is joule, and remaining as it is per Kelvin per mole. So this is the constant fixed value of R. So where R is the gas constant, we are calling that as a universal gas constant, or simply a gas constant, where R is having the value 8.314. If it is in this formula, joule per Kelvin per mole, if it is in liter bar per Kelvin per mole, means you have to multiply that by 10 raised to minus 2. So in probably all the cases we are getting the final expression 8.314. You have to remember here the SI unit is joule per Kelvin per mole. You have to write the SI unit without fail. So if you are writing this SI unit, means you have to multiply this by 10 raised to minus 2. We are getting the difference between the previous and this two. Both are same, only here we have taken 10 raised to minus 2. Here we are not taken 10 raised to minus 2. And the bar and liter is converted as joule. So this is the final expression. So now onwards you should be ready to say the constant value of R. R is nothing but 8.314, and you have to remember the SI unit also. So you may get a question like this. What is ideal gas? Derive the relation between ideal gas, derive the ideal gas, and derive the state and ideal gas, and derive the universal gas constant expression. Universal gas constant expression is nothing but you have to derive this one, or you may get the calculate the R value, calculate the universal gas constant. So for that reason, they may begin to ask you from the ideal gas. So keep in your mind the statement of the ideal gas and how they are dependent on the three laws, and that the final expression PV is equal to nRT you have to write, and from this you have to convert R, and you have to substitute the constant value of pressure, volume, amount of substance and temperature, and finally you are going to get the constant of R. So this is the universal gas constant expression or derivation to calculate the R value. So this is very important for your annual exams or even in the internal exams also. So this is most important. Write it properly and understand this. Be ready to write in the exams also. Okay. So the last one we observed that PV is equal to nRT. That is nothing but it is a representation of ideal gas expression. So in the ideal gas expression, PV is equal to nRT. So that can be rearranged based on the nR. So I am setting P to the left side, therefore PV divided by T. Why? Because it is into, it is converted as divided by PV divided by T is equal to nR. So here, so nR are the constant, number of moles of the gaseous compound, and gas constant is a universal gas constant. It will remain same for that reason. So if any change in its pressure, volume, temperature can be varies, but amount of substance and gases are remain same. For that reason, for P1, V1, T1 initial values of pressure, volume, temperature, we can convert it into the form of P2, V2 divided by P2. But N and R remain same. So by comparing these two, we can convert T1 to V1 upon T1. This is equal to nR, where nR is equal to P2 V2 divided by P2. Means these are the 6 terms. These are the pressure, initial volume, initial temperature. After some time, or after applying some changes, volume, temperature, pressure, if any one is changed, means according to that, P1 becomes P2, V1 becomes V2, T1 becomes T2. Means temperature, pressure, volumes, they are changing. So this expression is called as combined gas flow. Combined gas flow. This is called as combined gas flow. So based on this expression, you can able to solve the problems. How means? Can you see that here totally 6 terms are T1, 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 3, and this is 3. Among these 6 terms, they are going to give any 5 term, so that using 5 terms you can able to determine next last remaining one. They may give you any of the 5 terms. So these are the initial value, these are the final value. So based on that, you can be able to find the initial pressure or final pressure, initial volume or final volume, or initial temperature or final temperature. Are you getting? So this expression is called as combined gas law. Write the combined gas equation is nothing but this is called as combined gas equation. We derive this based on the ideal gas expression. So this is important. So it may ask you, or it will help you in the further educations. So for that reason, this is important. And next one is side heading, that is density and molar mass of gaseous substance. Here we are going to generate a formula which is going to have the relations between density and molar mass of gaseous substance. But we know that density is nothing but D. Density can be calculated by mass divided by volume. This is the density formula. Whereas molar mass is nothing but capital M. You should remember this term. So whenever you are writing notes, observe the video. I said already you. So by referring the video, you have to note down some points. Along with that, if I writing something important, you just write that on the margin, so that you are not supposed to forget the terms, because these terms are important. So density is nothing but small m divided by V. This is given mass divided by volume. Whereas capital M is the molar mass. So just now I said in the last classes also. So molar mass is nothing but it's the mass of 1 mole of the compound. So here we are generating PV is equal to nRT. So here PV is equal to nRT. So we can convert this expression as n divided by b means I am sending b to that side and I am taking rp to the left side. N divided by b, this b is moving that side, it becomes divided by, and rp is coming in the this side. P divided by rp and n divided by b is. So why we are writing like this means just to generate the density and molar mass formula. So we know that n is nothing but what? N is nothing but small n divided by capital N to calculate the number of moles. So I will write small m divided by capital N where v is there, small m divided by b into m. So remain p rp as it is. But we know that density formula is mass divided by volume. Therefore mass here small m divided by capital V. So m by v can be represented by replacing the d, density divided by capital N, where capital N is nothing but molar mass, that is equal to p divided by rp. So we need the formula of molar mass and density. Now we are having density and molar mass. So let's create the formula. M is equal to, so m is nothing but molar mass. You just send this m to this side. What happens? D is equal to m into p. You see here m is come to this side, so divided by becomes into divided by rp as it is, rp as it is. But I need the m equation. This is the density formula. If we want density with respect to the pressure, temperature, gas constant and molar mass, this is formula. Same thing, but we need m value. M is nothing but you just send rp to this side. M RT into D means D RT. RT comes to this side and just send P to that side. So divided by P. This is the formula. This is going to relate the molar mass of the gas and density of the gas. Along with that we are having gas constant, temperature and pressure. But this is the final expression by representing the molar mass that also containing the relation of density. Can you see here? Molar mass is directly proportional to the density of the gas. As the density of the gas increases, molar mass is also going to increase. Means density is directly proportional to the molar mass. You have to remember this expression. This equation can be rearranged as I expressed here. Can you see here? D is nothing but we just send the P here and RT. So we can rearrange this equation, but you should remember how to rearrange the equations. Okay. So these are the important concepts. So according to me, the last 5 gases law, ideal gas expression and determination of R, that is the very important according to me. And next one is, these are slightly important, combined gas, and then just write this side heading and write it as it is. So first you write PV is equal to nRT and rearrangement of this one. We are writing this one. And what about M means, and I have written here D is nothing but M divided by V, I replaced it. And by rearranging the equation, M is nothing but dRT upon M. So this is the equation going to give the relation between density and molar mass. After writing this one, you have to write what is M, what is D, what is R, what is T and what is K. So okay. So yesterday I asked you one of the question that is core, isocore, which one is having the greater volume and all. Very few you asked means answered. So very nice, that was the right answer. Very happy about that, and we will see how you are going to interact with the next videos also. So next I will solve the problems on these concepts. So be ready, and before I will send you some of the questions, and get ready to solve those questions in the next weeks. Okay, until have a nice day, bye.